Welcome to the MSQL Tips webcast, Key Benefits of Working with Azure Resource Manager, sponsored by SIOS Technology. I'm Greg Robity, co-founder of MSQL Tips and today's webcast host. Joining me today is Dave Bermingham, who will discuss how to use Azure Resource Manager for SQL Server. Before we get started, if you have questions, you can submit them at any time during the webcast by entering your questions in the questions area in your presentation controls. We will try to answer as many questions as possible during today's webcast. If you have any technical issues with the sound or screen quality of the webcast, also use the questions area to let us know. If you're not already a member of the MS SQL Tips community, we invite you to join. You can go to www.mssqltips.com and sign up for our newsletter, read tips, download white papers, watch videos, and post your SQL Server questions to be answered by our community members. This webcast will be recorded and archived for future playback, and you'll receive a follow-up email with links after today's event. I also want to let everyone know that Dave is going to provide some PowerShell scripts that he'll be using today, and there's going to be a link that he will show, and I'll put that in the chat as well as in the questions. You can actually download all the scripts, and I'll do that several times during the webcast today. So at this time, I'm going to turn things over to Dave, and he can begin.
Thanks, Greg. Again, my name is Dave Bermingham. I am a Microsoft Cloud and Data Center MVP, and I've been working with SIOS technology for coming on 12 years now. I'm currently the technical evangelist, and in my job at SIOS, I'm really focused on high availability for business critical applications. For the past couple of years, I've been working with Azure, and with Azure Resource Manager, really the past year, it's become to be the preferred method for deploying in Azure, but it's kind of deploying highly available SQL Server with Azure Resource Manager is there's not a lot of information on this topic, so I hope you find this information useful. So we're going to start, we're going to have a general overview of what Azure Resource Manager is, and we're going to look at some of the management options for Azure Resource Manager. And then we're going to spend the majority of the time looking at deploying highly available SQL Server in Azure Resource Manager and what it takes to do that. So we're going to start it with what is Azure Resource Manager, and you can think of it really as, I think of it as Azure 2.0. It's really the new paradigm that Microsoft wants you to use in deploying your Azure deployments. And the old version, you might see it called Azure Classic, or the real name is Azure Service Manager, is deprecated. It's still there, and there's many deployments out there now. But if you are looking at deploying in Azure today, you really want to leverage the Azure Resource Manager, the version of Azure Resource Manager, because all the new features are being released in Azure Resource Manager and not so much in Azure Classic. Moving from Azure Classic to Azure Resource Manager can be a challenge, but it's something that if you're currently deployed in Classic, you should probably plan to make that migration sometime in the near future. So the key features of why you would want to use the Azure Resource Manager. One is this concept of managing resources as a group. Prior to Azure Resource Manager, there was no way to really group resources together in any logical fashion, and now they have something called a resource group, which we'll take a closer look at, where you can group your resources in a logical fashion, whether you group all your resources for a single application into a single resource group, or maybe you group all your network resources in one group and all your virtual machine resources in another group and your storage resources in another group. And so you might have different people managing different portions of your infrastructure. So you can really group it in whichever way makes sense for you. Using templates, you can have consistent deployment. So we'll take a look at some of the Azure templates that are published in GitHub, and also take a look at deploying your own template so that you can consistently deploy multi-tier applications with dependencies upon different tiers, so that you have things launching in the right order and have dependencies and whatnot. So all that is a feature of Azure Resource Manager, which is previously not possible. And then we have new access control. So you can control access at the resource group level, or you can control access all the way down to the individual resource, and we'll take a look at how to do that as well. So you don't have to give someone the keys to the kingdom if you want them to work in your Azure environment. You can really give them just very specific control to just individual resources. And then the concept of a resource tag. You can tag make custom tags and tag each individual resource so that it's easy to sort and to find things you're looking for, but it's also great for bill back capability. So if you have multiple departments sharing your Azure resources and you want to be able to divide that bill amongst different departments, the resource tags will give you that capability to tag your resources so that you can split out the cost of the Azure across multiple departments. So before we begin, I'm just kind of getting an idea of the participants to your level of experience in Azure. So we're going to start with this first poll question, essentially, have you used Azure, and have you used Azure Classic, Azure Resource Manager, or both? So Greg, if you pull up that poll question, we'll get started with that.
All right, so the first question here is, who has used Azure Infrastructure as a Service? And the options: Classic only, Azure Resource Manager only, both ARM and Classic, or none. So we'll just take a few seconds to let everybody vote, and then we'll share the results. And so far, it's looking like most people are on the none side, but again, we'll give it another 10 seconds. We'll close this poll and share the results here. So if you haven't voted, please vote. All right, I'm going to close this and I'll share the results. So we have 66% said none, 23% said Classic only, 11% said both ARM and Classic, and 0% Azure Resource Manager only.
Okay, great. Well, that gives me a good idea of your experience. So that's very helpful. So first thing we want to do is look at managing ARM and what are your options for managing ARM. The Azure PowerShell 1.0 is the latest release of the PowerShell that will manage ARM. So prior to Azure PowerShell 1.0, there was earlier versions of PowerShell. So if you go out to this this link here, you can download a version of PowerShell that's specifically made to manage your Azure deployment from your local workstation. So you definitely want to get the latest version of PowerShell, and then you can use PowerShell to manage ARM. Of course, there's the Azure portal, which we'll take a look at in detail in this demonstration coming up in a moment here. So those are two ways that you've been able to manage Azure, even in the classic version through PowerShell and the portal. But now there's the concept of these Azure deployment templates. So out on GitHub, there are numerous predefined templates that you can leverage either as is or to take the code examples that are out there and customize them to your specifications to help you deploy your resources consistently. And also, there's a whole REST API that you can leverage. So if you want to leverage the REST API, a link is here to do that. And if you are on other clients other than Windows, there's an Azure command line interface that you can download. So you can manage Azure through Mac or Linux or Windows as well. So let's take a look at some of the options here. So I have a demo. All my demos today, I did some screen capture so I could cut out some white space so we could cover a lot of material in a shorter period of time, and also leverage some magnification so we can see things a little bit better. So this first demo is that of the Azure portal here. So again, portal.azure.com will get you to this new portal. This has been in preview for quite some time, but now it's in preview in the publicly GA. So there's lots of different things you can do with this portal. One is you can, if you have multiple subscriptions, you can select what subscription you want to view. You could choose a theme. I have the dark theme currently selected. It's a nice view that I like to use. You can also control your different language, use English or any other languages. Up at the top, you can also control what your dashboard looks like. So you can filter by resource groups or by tags, and you can also move things around. So you can drag things around, you can delete things. So it makes it very customizable. So you can put things right on your front page that you access on a regular basis. In the left column, all these resources, I have mine kind of configured the way I like to see all the resource groups in virtual networks, virtual machines. But if you click on Browse, you can see all the possible Azure resources. And if you click on the star, then that resource will appear in the left panel, so you have ready access. So it's very customizable, user-friendly. You see here I'm going to add the marketplace to my my shortcut list here by just clicking on the star, and then my marketplace will be available. And that will be saved for future anytime I log in here. All right, the other important thing is the resource groups I mentioned. So if you click on resource groups, you can see I have, in this particular configuration, I have 2 resource groups configured. I'm going to click on a resource group called SIOS East, and we'll see what we have going on here. So if I click on that resource group, I have a list of all the resources in the middle. I click on the little ellipse here, I can drill down and look at all my resources. And so this is a list of all my resources in this resource group. You can see there are numerous different types of resources. There are availability sets, virtual machines, load balancers, network interfaces, so all organized in that resource group, and they're all part of that Azure East resource. And from here, we can drill down further. If I want to click on a virtual machine here, I have a virtual machine always on, I can click right on that virtual machine and then get properties of that virtual machine right here from the resource group. So lots of different ways to navigate. As you probably notice, this portal kind of continuously opens to the right. So as you drill in deeper, more columns appear on the right to give you additional information. So I go look at the properties of this virtual machine. See it's running, the IP address. And across the top, you can see, if you get lost of where you are, you can kind of see the breadcrumb trail of where you are. So right now we're at the properties, the settings, the always on. So it's very easy to navigate by leveraging that. So I click back on resource groups and go back to main resource. And then there's a history, so you can look at the history of where you've been to quickly travel and traverse this GUI. The other part of the management, we talked about GitHub. So I'm opening up GitHub. You see that IP address, the URL, github.com/Azure. So this is basically Microsoft's repository of what we call these Azure resource templates. And there's so many templates, so much information out here, but the important repository you want to look at is coming up here, this Azure Quick Start templates. You click on that, you're going to see a whole list of templates that really kind of will give you either the baseline templates for doing things like creating site-to-site VPNs or security groups or whatnot. So there's all kinds of really great templates that will are easy way for you to get started in deploying resources in Azure. So the one template we're going to take a closer look at is that Microsoft has published a template that is the SQL Server 2014 Always On deployment. So by clicking on this template, we will go in and we'll be able to actually here's all the files. You can look at these files, you can look at the JSON templates, so you can see exactly what they're doing. And again, you can customize these for your own use. If you're going to write your own JSON or customize, you're probably going to want to get a hold of Visual Studio and the Azure Management Pack. And that's going to make it easier for you to be able to work with JSON, which is probably a new technology for many Windows administrators. But if you're going to be leveraging or managing Azure Resource Manager on any grand scale, it's definitely a skill that you're going to want to acquire. But for simple, if you want to just get started, this script, this template will deploy a full-blown SQL Server 2014 always-on availability deployment from scratch. You see here it's going to create a virtual network, storage accounts, load balancers, domain controllers, SQL servers, and everything automatically for us. And all we have to do is click on this button that says Deploy to Azure, and that's going to actually launch the portal. It takes us to this template, and within this template there are some parameters that we will fill out. So you see we edit the parameters, and we're just going to give the storage account name. You have to create a unique name for your storage account. So find a unique name. Prefix, this is just what's going to be put in front of all your resources. So you give that a name, and your DNS, this will be your DNS that's created for you when they create the domain name. And it's going to ask for some service account names, so it's suggesting some service account names. You're going to create a password, so you type in your password here. It's going to create the virtual subnet. You can see the network address range is going to be used, and the subnet and the actual IP addresses. And some admin usernames and passwords, we'll create those as well. And then you can deploy this in multiple locations. So we'll choose the US East location. And it's going to create two, for this, SQL Server, we're building a always-on availability group. So it's actually going to create two test databases and put it in an availability group for us. So you see the database names here already filled out for us. And so you notice I forgot to put the admin password in, so we'll type that password in and then click OK and deploy that. So that will go, and one other thing we need to do is we'll go, before we create it, we'll select the resource group we want to place this in. So we could choose an existing resource group, or we can create a new one. And so pick your option, whatever you want to do. Once you've done that, you click on Create, and that will deploy. Now, before you go off and do that, you should realize that by default, that template will create some preview storage accounts for you, which will burn through some Azure credits pretty quickly, so just be aware of that. All right, so that is, the introduction to Azure Resource Manager and some of the ways to manage Azure Resource Manager. There's lots of good information, deeper dives on JSON and whatnot. If you go out to Channel 9, Microsoft Channel 9, and just Google for Azure Resource Manager, there's some great sessions from recent Ignite sessions out there, and I'll give you a little bit more information. But for this webinar, we really want to focus on SQL Server and high availability, and how to deploy highly available SQL Server in Azure Resource Manager. So the foundation of any deployment is the virtual network. That gives you your playground in Azure, and it also enables hybrid cloud configurations. If you want to span from on-prem into cloud, you're going to have to leverage the virtual network. So quick demo on how to create the virtual network using the portal here. In this demo, we're going to create a new, click on New, we're going to create a new Azure network. So you see there's lots of different resources you can create. We're not going to go into all these, but the one that we're going to look at here is under networking. So we'll click on networking, and we'll click on New Virtual Network, and this will launch the wizard to create the virtual network. One of the things you want to notice is you have an option. You could choose to create this in Azure Classic or Azure Resource Manager. One thing you should definitely know is the two do not intermingle. So if you're going to do Classic, all your networks and virtual machines and storage all will need to be deployed in Classic. Vice versa, if you're doing Resource Manager, everything will need to be Resource Manager. They really can't play together. So we're going to choose Resource Manager and click Create, and then we'll answer some questions about this virtual network. One of the questions will be, we'll just give it a name. We'll choose an address space. It defaults to some common spaces, and then we can divide that address space into multiple subnets. This default subnet, I'll change the name of that and call that the public network. Your subscription, if you have multiple subscriptions, and again, resource group. If you You can choose an existing resource group, or you can create a new resource group right from here, and then location where you want to put this virtual network. So we'll choose the US East 2, and all that looks good. So we'll that's submitted for deployment. Once it's created, then you can come in here and you can edit it. So we've created that. This is illustrating some of the tags I mentioned earlier. So if I want to tag this virtual network with a department name, I could do that by clicking on the tag and add that tag so that the accounting department can be billed for this particular network. I can also specify specific DNS servers that this virtual network will use. All virtual machines being deployed in this network will by default use whatever addresses I provide here. Once you have a domain, you probably want to put your domain controller DNS server as the primary DNS address there. All right, so we'll choose that, save. Here's the user. So I mentioned that you can add users. So by default, the subscription owners have full admin rights to this, but I can add users in specific roles. So I'm going to select a role, and I'm going to have a contributor, and I'm going to invite a contributor to manage this network for me. So as long as they have a Microsoft account, I can add that and invite them to be a contributor for just this particular resource. So that's how you would go ahead and control access on the individual resource basis. Okay, so now we have the basic virtual network created. Now, one thing we need to be aware of is something called availability set. So Azure will give you a 99.95% service level agreement if you have 2 or more virtual machines deployed in an availability set. And by deploying virtual machines in an availability set, what it does is it puts each virtual machine in a different fault domain and a different upgrade domain. And this link that you see here goes into some great detail about what fault domains are and what upgrade domains are. But essentially, a fault domain you can think of as a rack of servers that has no single point of failure between another fault domain. So if you put your SQL Server resources in different fault domains, you can be sure that an unexpected failure should only impact one fault domain at a time. One of the greatest improvements of Azure Resource Manager is that they by default give you 3 fault domains now, where before in Classic they only gave you 2 fault domains, which for high availability deployments was not adequate. If you're familiar with clustering or availability groups in the quorum model, you really need to have 3 votes in your cluster, and each vote should be in a different fault domain to assure that the failure of a single fault domain only impacts 1 vote at a time. Azure Resource Manager, if for nothing else, you want to use Azure Resource Manager for your SQL deployments because you have 3 fault domains by default now. Upgrade domains are essentially Microsoft's, they guarantee that they will only, when they're doing planned maintenance, will only impact 1 upgrade domain at a time. So by putting your instances in an availability set, it spreads the instances across different upgrade domains so that planned maintenance does not bring down your entire cluster. So to do that, we'll see in this next demo, we'll choose an availability set and we'll put all of our virtual machines in that same availability set. So we'll jump to the demo here, and we're going to create a new virtual machine. So again, we'll start on the left, click New, and we're going to click on Compute, and then we're going to choose the updated Windows Server 2012, and we'll go ahead and choose the Resource Manager and click Create. And this will launch the Creation Wizard. We have a couple other parameters to fill in. So the basic configuration, we're going to give this virtual machine a name. This is going to be my domain controller. So let's start with my domain controller, and so give it a name, DC100. Username, this is going to be created as a local user account, and password, so whatever you put in here will be part of this deployment. By default, this virtual machine will be accessible by RDP as well, so that's how we're going to connect to it. So resource group, I'm going to put it in the existing SIOS East resource group in US East location. Looks good. Once that is, we do that, then we can choose the virtual machine sizes. There are lots of different options here. So for demo purposes, we'll choose the basic standard version. But as you can see, basically there are options to do multiple cores, lots of RAM, and really basically the more money that you spend, the more resources you're going to be able to leverage. Sorry, I messed up here. 1 second. Jump forward. Okay, so where are we? Here. Okay, so we're going to choose the D1 standard, which is going to give us 1 core and 3.5 gigs of RAM. And then some optional settings. We can go into the network and choose the storage type. Again, premium storage is great, but it's going to cost you some money. So for demo, I'm going to choose standard. Create a storage account. That'll create a new storage account for me automatically. We'll put it in the right virtual network. IP address, it creates a public IP address by default. That's how we're going to connect to it via the RDP connection. Security groups are interesting. So security groups basically by default, the default security group allows RDP connections from the public network. You can go in and edit that after the fact to add additional restrictions or to loosen the security. I like to leverage the security groups instead of the Windows firewalls to have more centralized management and more consistent deployments across multiple servers. So that's something you probably want to look into as well. And the important thing down here at the bottom is this availability set. So we're going to click on availability set and create a new availability set. For our deployments, we're going to put the domain controller and the 2 SQL Server machines in the same availability set. So I'm giving it a name. You can see here by default it gives us 5 update domains and 3 fault domains. You can increase the number of update domains, but default domains, the max is 3. So we'll leave the default settings and create that. And we'll go ahead and we'll launch that deployment. And essentially, we're going to recreate this and do this 2 more times to create the SQL Server virtual machines as well. But we'll skip that just so you know we're going to create the 3 virtual machines that we're going to use for our demo coming up in just a moment here. So once you're done, it'll submit. One of the really great things about the Azure Resource Manager in comparison to Azure Classic is that you can do multiple things at once. So if you've used Azure Classic before, you're probably familiar that even starting and stopping virtual machines, you have to wait and wait and wait for one thing to complete before you can try the next thing. With ARM, you can do multiple things at the same time. So it helps to serialize the process and speed things up a little. So once I have the virtual machine created, I can come into the properties, and we'll probably want to come into the properties and look at the network interfaces, and we're going to create a static IP address. So click on IP addresses, and we'll look at the properties of IP. By default, it uses DHCP, which could potentially give you a different IP address each time you launch the virtual machine. So we're going to change that to static and pick the IP address so that my domain controller is going to keep the same IP address all the time, which is going to help things out a lot. So we'll save those settings, and that will update that virtual machine. DNS servers, you can use custom DNS. Now, before when I told you that we changed the DNS, the default DNS for the Azure Virtual Network. Now, in Azure Classic, I've seen when I change the default DNS server, the Azure virtual machines deployed in that Azure network will automatically take the new DNS server. I don't see that behavior in Azure Resource Manager. I'm not quite sure why. So I do have to go in and change add the custom DNS for each of my virtual machines. I'll have to really investigate that a little bit further, because I would expect that the virtual machine in the virtual network should use the default DNS servers, but they don't. And again, you can add tags to this virtual machine. So you go back to the department tag and put whatever department you want, so that, again, help with the billing and for management of these resources. All right. So now we have a virtual machine configured. We can think about the storage for a virtual machine, and we really haven't talked about availability yet. So in Azure, same as on-prem, there are a couple of options for providing high availability for SQL Server. One is always-on availability groups. If you're using SQL Server 2012 Enterprise Edition or 2014 or 2016 coming soon, you can use you can use the availability groups. The storage options that you have for availability groups are, you can use the local regular storage, you can use premium storage, or Azure file services. You can also build an always-on failover cluster instance. For that case, you can only use the Azure file service, which is a new resource that Azure offers. It's basically an SMP 3.0 file share. Or you can use third-party replication resources like the SIOS DataKeeper solution, which we'll look at in a little bit. So those are really your options here. And so we're going to add some storage to the virtual machines, and we're going to talk a little bit more detail about the performance of those different options. So to do that, again, you go back to your virtual machines. You're going to look at your virtual machines. I've pre-configured the SQL 101, and look at the settings of this virtual machine, and go over to the disk, and we can see that there's currently only the OS disk. It's going to attach a new disk, and there's some options here: standard storage or premium storage. We'll just choose the standard storage for now. We'll add a disk to that virtual machine, and we'll come back and we're going to add another disk. So one of the options I mentioned we're going to talk about is creating storage pools on a virtual machine. And so if you add multiple disks to a virtual machine, you can later go back into that virtual machine and create a storage pool that will give you greater IOPS. So you see here, you're limited for standard storage, you're limited to 500 IOPS and a throughput limit of about 60 megabytes per second. So you're going to want to look at something with better performance there. All right, so we'll create the additional disk, and then at this point we're ready to optimize the storage. So I wrote a blog article that goes into great detail about optimizing storage, and one of the options I mentioned is to create a storage pool. So I did some measurements using disk speed, and I had 3 storage options. The F drive I provisioned with 3 1 terabyte premium storage solutions created in a simple array, which is like an array 0 for performance reasons. And the G drive was just a single terabyte premium storage array. And then the Z drive would leverage the SMB file share using Azure File Services. And you can see the chart illustrates the performance I was able to see. Of course, the F drive with the 3 disk in array 0 gave me the best total throughput, both read and write, and minimal latency. The Z drive had an incredible amount of latency, which primary reason is right now the Azure Files service does not support premium storage, so it's not really a viable solution right now for SQL Server workloads. So we're going to quick demo that shows you how to create a storage pool. If you're not familiar with storage pools, under Server Manager in the file and storage services, there's a quick wizard that you can launch storage pools, you create a new storage pool. And assuming that you have those disk attached that we attached earlier, you'll see this in the storage pool. This pool name. Here are the 2 physical disks that are attached to this virtual machine. And we'll create the storage pool. And close that. And then once this pool is created, we have to create a new virtual disk. So you can right-click on that, say new virtual disk, and we'll walk through this process. Give the disk a name. And here's where we have the choices. Now, simple, you might be worried about creating a simple array because you're worried about you lose a single disk, your whole array is going to go away, and that's normally the case. But on the back end, Azure actually has the storage copied 3 times, so there's redundancy on the back end, so you can be confident that creating a simple array is not going to give you any less availability. It's going to give you just better performance. So create that disk, and then we'll leverage that disk for SQL Server, so maximum size. And that will complete. And then we create the partition on that disk. So pretty standard, straightforward stuff. One thing to realize is you should do this before the cluster is created. If you already have a cluster created and you try to run the storage pool wizard, you're going to have all kind of problems. There's a PowerShell command available out there in an MSDN site that will help you create storage pools after clusters are created. So you're definitely going to want to look into that if you do that after a cluster is created. All right, so we have our VM provision, we have storage optimized, we're ready to get started. So regardless of whether you're going to deploy an always-on availability group or a failover cluster instance, the basis for that is going to be failover clustering. And just like on-premise, it's pretty straightforward. You're going to configure your domain, add your servers to the domain. SQL Server is going to want the .NET framework to be .5 with all the cluster nodes. Failover clustering is a feature on the cluster nodes. One thing you do need to realize, you're going to want to create the cluster via PowerShell to avoid IP address conflicts. We'll talk about that in some detail. Then we're going to leverage a file share witness, because in Azure there is no disk witness that we can leverage. And the firewall, of course, we need to make sure that SQL Server can speak to each other. So I generally turn off the Windows firewall and use Azure security groups. So this demo here is going to walk through the process of creating the failover cluster. So we're going to open the Failover Cluster Manager. And the first thing we need to do is validate the cluster. So the validation wizard, again, this is pretty straightforward, just like any other cluster you've ever created. Of course, when you create this cluster and you run the validation, the validation report is going to come back with some warnings about storage, because there is no shared storage, and also network, because there's only one network. You can ignore those warnings because the network is redundant on the back end, and then the storage we're going to leverage either third-party replicated storage resource or the always-on availability groups. So I jump forward, and this is basically the report you're going to see. It's going to warn you about networking. We can ignore that error or that warning, and it's also going to warn you about storage. You can ignore all those warnings because we know we don't have shared storage in Azure to begin with. So once that is done, you can click Finish, and we're going to go ahead and get started with the cluster creation. Now, this is the PowerShell to create a cluster, and you're going to want to use the PowerShell to create the cluster because Azure has this issue, kind of a weird issue. Sorry, jump forward here. Okay, so Azure has this weird issue where the virtual machines still leverage DHCP even though we gave it a static IP address. And if you were to create the cluster via the GUI, actually Azure would give you a duplicate IP address. It would issue the same IP address to the cluster as the static IP of that server. To avoid that issue, if you create it via PowerShell, like you see here, and specify the static IP address that's unique, you can avoid that whole mess. So I highly recommend you use PowerShell to create your initial cluster. So that will create the cluster and the computer object and Active Directory. And I jump forward here to save some time. That's created. Well, then we can look at Failover Cluster Manager and see the cluster we just created. Here's this cluster called My Cluster. And the next thing we're going to want to do is add the file share witness. So we're going to jump over to my domain controller, and we're going to create a new file share witness. So this is going to be on a third server. So this is on some other server in your network. We're just going to create a folder, and we're going to give the computer object we just created when we created the my cluster resource, created a computer object. So we're going to give that computer object read-write access to this folder. So on the share level permissions and the NTFS level permissions, we're going to add the computer objects. So I have to choose computer objects and search for my cluster. Check name and give it change permissions, and then same with the security. We're going to add the my cluster computer object. And once we set up the permissions properly, we can jump back to the Failover Cluster Manager and run the wizard to add a file share witness, which we'll see here back in Failover Cluster Manager. More actions, configure cluster quorum settings. Again, this is nothing new, nothing unique to Azure at the moment. We're going to select a file share witness. All pretty standard clustering stuff, pretty well documented out there. So we'll browse to the domain controller, and we will see the quorum folder we just created. We'll say OK, and there we go. So we just added the file share witness, and now my cluster is ready to go for the next step. So the next step, we have to choose whether we want always-on availability groups or an always-on failover cluster instance with SIOS DataKeeper. So again, in Azure, there is no shared storage, so typically a failover cluster instance would not be possible. There are two ways to do a failover cluster in Azure. One is to leverage the new file services resource, which we just saw had very poor performance, or you can use SIOS DataKeeper. And of course, always-on availability groups is another option if you're on SQL Server Enterprise Edition. You can do that. Always-on failover clustering will work with Standard Edition for a basic 2-node cluster. For this demonstration next, we're going to look at the failover cluster instance leveraging the DataKeeper resource. So once we have the cluster created, DataKeeper is a simple install. You run this setup on both the cluster nodes, and when that is done, we'll launch the DataKeeper wizard. So I'm not going to walk through all that. It's pretty simple. Next. The DataKeeper wizard is simple enough. Once we have it installed, you see these servers have the F drive attached to them. We're going to create a new job. We'll call it an F drive and create that job. Choose the source, and then we'll choose the target, and we'll choose the synchronous mirror and click done. And that's going to create a mirror of the F drive between those two servers, and it's also going to register a DataKeeper volume resource and failover clustering. Essentially, the DataKeeper volume resource takes the place of a physical disk resource, and the failover clustering just sees it as it looks like a shared disk, but under the covers, it's a replicated disk. So in available storage, you'll see this DataKeeper volume resource. So now that we have storage available, we can run the SQL Server setup. Again, just like a normal cluster, we're going to do the installation of a failover cluster and I cut out a bunch of white space here to speed this up so we can see the installation process. It's pretty standard. You walk through, accept the license terms, it'll run and check all the rules and regulations. You can get the updates if you'd like. Install the setup files and click next. We're going to install, for this demo, just basic database engine and all the management tools. But you can install whatever you like. Next. We'll install the default instance. You're going to give it a name, so we'll call it the SQL Cluster 1. That's where your clients will connect. Cluster resource group, we'll choose the default settings. Here, the disk, it recognizes the DataKeeper volume as an available storage type, so we'll choose that. Again, IP, we're going to give a static IP address, so this is going to be a unique IP address for this resource. In the future, we're going to leverage this same IP address, and we'll see the next demo for the internal load balancer, which we'll talk about next. So we'll have the 201 as the address here. Of course, you have to give your service account name and password. So use best practices here when creating your service accounts. Nothing different here than on-prem. All right, and so this will install, and of course, so this goes through as normal. I think I'm going to skip for sake of time. We'll skip this. So we'll just do this install, and then you'll run the same installation on the secondary server. You're going to have to install. You don't have to add a node to the SQL Server cluster. It works just like the same. So we'll skip forward for sake of time here and get to the meat and potatoes. What you really need to know about Azure is that there is a requirement to use the Azure internal load balancer or external load balancer for client connectivity. Essentially, Azure networking does not support gratuitous ARP, so your clients cannot connect directly to a client listener. So whether you're building a Failover cluster instance or an always-on availability group, you have this concept of a cluster name and IP address. Your clients cannot communicate directly with that. Instead, it has to communicate through the internal load balancer, which then redirects the traffic to the active node. I'll show you how to create that with ARM. It's not very well documented yet. I think my blog is one of the only resources available to document this process. So we're going to walk through this demo. And these are the scripts that Greg mentioned are available for downloads. We have them put in a nice zip file for you. So we'll walk through this. Essentially, we're going to leverage PowerShell to, first we're going to select the appropriate subscription. Then we're going to, if you're not leveraging the Azure PowerShell 1.0, you have to switch to the Azure Resource Manager and add your Azure Resource account. So this is just getting it set up so we can go ahead and create the internal load balancer. Hit the login every time you want to leverage Azure PowerShell. So we'll go ahead and do that. So again, all these scripts we provided via the zip. I've documented this on my blog. You'll see at the end a link to my blog as well, so you can look at that. This is the script that it creates the load balancer. So without going into great detail, you're going to collect some information. You're going to have the resource group name, Azure East. You're going to give a front end, a back end configuration name. These could be anything you like. The load balancer name, again, could be anything you like. The location should be the location where your load balancer is deployed. Subnet name, you remember I changed in my virtual network, I changed the default subnet name to public, so you're going to make sure you specify the right public name. And then the load balancer IP address, this is going to be the same IP address that we just created when we installed the SQL Server cluster. You know, it's 201, that's the IP address. So you're going to want to edit your script with the parameters appropriate for your environment, and then this PowerShell command will run to create the internal load balancer. Once it's created, we'll see it in the Azure portal, and then we're going to make some edits to the Azure portal to further configure the load balancer to redirect the SQL Server traffic. All right, so in the portal now, if I click on Azure East, we'll see this resource called internal load balancer. So a moment here, see this ILB East, that's what we just created. So there's some final configuration we need to make this so that it actually redirects the traffic. First thing we're going to want to do is create the backend pools. So click on backend pools, and we're going to choose the virtual machines and availability set. So click on here, and we'll add the availability set that these virtual machines sit in. So we'll choose the availability set. If you remember, I created this availability set earlier, called SIOS East, and I'm going to choose the virtual machines I want the load balancer to direct traffic to. So we're going to choose the two SQL Server, two cluster members, so SQL 101 and 102. And then we're going to want to save this. And we're going to close this out here. So that's the backend address pools. We need to create a probe. So this is how the load balancer is going to know which node is active. So we'll create a probe. So click on Add Probe. And I'll give the probe a name. TCP, we're going to use port 59999. The interval, so by default it probes every 5 seconds, and after 2 minutes heartbeats it will take it out of the load balancing set. So that's probes configured, and then we need to configure, I think the load balancing rules are next. So we'll click on load balancing rules, and this is, we're going to redirect the 1433 traffic. So the SQL Server traffic, we're going to add a rule for that. So we'll click on Add Rule, give it a name, call it whatever you like. So SQL 1433, port 1433, and then backend port is 1433. And then there's one other setting you need to change to enable the floating IP address. You have to enable that, and then click OK, and that will create the rules for the internal load balancer. Okay, now after the load balancer is created, there's one final step we need to do. We actually need to connect to one of the virtual machines and run this script. So again, this is something that is part of the zip that you can download. And this basically tells the SQL, the cluster IP resource to start listening for the probes and responding to the probes. So that script, it has, again, some of the parameters you're going to want to pass is the cluster network name, the name of the IP resource, and then the IP address that the internal load balancer uses. So you pass those parameters, and it will adjust the cluster IP address so that it can start responding to those probes. And you also have to restart the SQL IP resource in order for that to take effect. So you're going to want to go ahead and stop the SQL Server resource and restart it. So I'm going to move forward for sake of time to so it allows some time for questions. Again, you can find out more information and some step-by-step detailed instructions. Everything I showed you here today on my blog, clusteringformirrormortals.com. And you can email me or reach me on Twitter at Dave Berm. If you want more information about SIOS technology, here's our website and telephone number and our Twitter handle there as well. So, Greg, why don't we take this next 5 minutes or so and answer any questions that might have come in.
Okay. Yeah, if anybody else has questions, feel free to type them in at this point. So just one question. This was kind of early on in the presentation. Someone just asked, can the Azure Resource Manager deploy SQL databases? And what's the minimum version of SQL Server? So I'm not sure they have all the terminology right there, but
yeah. So Azure Resource Manager. So there's Azure SQL. So maybe we should clarify this, right? So Azure itself is a big umbrella. It does lots and lots of different things. We were speaking specifically about Azure Infrastructure as a Service, which is basically gives you the framework to deploy network storage, virtual machines, and basically build your own cloud service. There's something called Azure SQL Server, which is a platform as a service that is essentially hosted SQL Server that Microsoft manages that you can then build on top of that. And that's, that is certainly an alternative if you're building new applications and you don't need, all the features, all the bells and whistles of SQL Server. You can look into that as well, and that's entirely something different. So I'm not sure if that's what the questions was in reference to. Azure Resource Manager itself, by default, is not going to create databases inside of virtual machines that you provision with SQL Server. But as you saw through JSON and templates, you can really do anything you want. So that one template that we looked that was deploying an entire always-on availability group configuration, if you notice, that template was creating databases. So a part of that JSON configuration was to call into some PowerShell that was being executed inside that virtual machine as part of the deployment process. And SIOS itself is actually going to be launching a template that does the same thing for the always-on failover cluster instance. I was hoping to be able to demonstrate today. We're close to having that available, but we're still probably going to be another week or two away. But so yeah, to answer your questions, yes, you could do it, but it's going to take some work. You're going to have to work with JSON and create some custom templates and some PowerShell.
okay. The next question, Dave, is related to the GitHub, and you showed the resources to deploy the always-on availability groups. Somebody's just wondering here, are there other templates out there that can be used for SQL Server out there that you're aware of that might be useful to?
Yeah, I mean, you could browse that GitHub. It's dynamic, just like the cloud, and it changes daily. So there's new things. I discover new things all the time, and I think the GitHub is really a great place to start if you're not familiar with JSON. Definitely, you're going to want to educate yourself on the parts of the JSON template. There's a really great, I wish I had the link, but there's Channel 9, just the latest Ignite conference, I think it was Australia maybe a month or two ago. Great presentation that goes over JSON and in some detail as a kind of introductory. And so the GitHub has so many example deployments of just about anything you can imagine, and there's new stuff being added daily. So the one I demonstrated is great if you just want a quick deploy a always-on availability group. That's going to do everything for you, soup to nuts, including creating domain controllers, virtual networks, SQL servers, configuring always-on, the whole 9 yards. And it'll just, you click it. It takes probably about 20, 30 minutes before the whole deployment completes. But when you come back, you can start kicking the tires on the deployment.
Okay. The next question is related to that whole Azure platform. To go through that, is there a cost to do that, or does Microsoft offer any free way of doing that, or is it the cost minimal for somebody to actually go out and do some testing?
Yeah, I know. I think MSDN subscribers get some credits, so I use MSDN subscriber credits. I think I get $150 a month, and as long as I've got to be careful not to deploy premium storage, because you could charge and you could burn through those credits pretty quickly. So yeah, so there are some free trials. I'm looking at their webpage right now. If you go out to azure.microsoft.com, I see a button that says free trial. Not exactly sure what that gets you, but you definitely check it out. I'm sure you're going to get at least a few dollars towards being able to try out Azure and kick the tires.
All right, fantastic. Well, we're actually out of time. I'm going to wrap things up. So thanks, Dave, for sharing all that great information. Those videos and walkthroughs are definitely great. I also want to thank SIOS for sponsoring today's event. So please visit SIOS at us.sios.com to learn more about the SIOS solutions for SQL Server high availability and disaster recovery. The webcast was recorded, and you'll receive a follow-up email with links to view the archive. We'll also include a copy of the slides as well as the PowerShell scripts that Dave showed during the demonstrations there. Also, please visit mssqltips.com to access all of our free SQL Server resources. Once again, I'm Greg Robity from MS SQL Tips. Thank you for attending and have a great day.